One is really general, and one is quite specific to JavaScript. I think if you forget everything else in this talk, that may still be kind of valuable, what you learned in these two ideas. But we're going to get to some code and demos soon. I want to start with what I think is the most important idea in software development, cognitive load. It's quite a simple idea that seems in some sense to me to obviously be true. In whatever context, time, place, we have some available mental energy or capacity to do stuff. And when we try and do something, some of that will be consumed by the stuff in red, which I think of as like the state management framework, the framework, the programming language, the colleagues you have to put up with. And then the stuff in blue, which is the stuff that's actually relevant to solving the particular problem at hand, or to build the feature, to build a great user experience. And I think often the problem is the stuff in red gets so hard and so complex that we simply don't have enough energy to accomplish the task we want to. If you want to learn more about this, Kira Hodgkinson's talk at ReasonConf last year is great. You should catch it on YouTube. And this idea is kind of, I think, related to things like essential and essential complexity, the Clojure guys stuff. Things like having a compiler that acts as a pairing assistant. It gives you advice. It tells you what you might have done wrong. It takes mental load that you have to think about and moves it somewhere else. There's traditional object-oriented stuff like encapsulation and things like functional programming, where you talk about things that are easy to reason about, so immutability and so on. That's the general idea. The specific idea, what I say about JavaScript and what influences things like creating a state management library. I started in 2012 or something. I didn't really do JavaScript then, but in 2012, Java was rubbish and we all wanted to move to Node because it was really agile. But what is agile? Agile is something that is easy, relatively speaking, so it may still be quite hard to change or iterate. But here's the thing, JavaScript is not agile. This is, I think, a really common misconception. In JavaScript, the cost of changing stuff is really, really high. Now, as people pay to write software, this is awesome, because every 2 years, your stuff is so complex, you have to just throw it all out and start again. This is amazing. And projects, they get so difficult, they need to throw people at it to try and solve the problem. So we all get jobs and get paid well. That's great. But it also has problems. There's a huge cognitive load and a huge pressure to get the structure of your application or whatever you're building right first time. And there's something like tests don't really directly help with. Tests kind of help within the context, within a particular structure, that it does a kind of expected behavior given expected inputs. But they don't really help us if we decide, oh, yeah, we've messed this up, we need to really change it. You basically delete the test and create new tests. You delete the code, you create new code. You basically start again. So in thinking about JavaScript for anything, but in particular state management, you have to ask, what is JavaScript? So it's not agile, but what is it? So I think of JavaScript as being flexible. It's like cement. So you've got some really rough ground. If you pour cement over it, it's going to smooth and fill in all of those cracks, all of those SOAP, XML, legacy awful things, and the GraphQL shiny new things. It will glue those together. It's possible to do that in JavaScript. It's also really awesome because it's really dynamic. You get very fast feedback. You don't have to wait for a thing to compile. You can get hot reloading and that kind of stuff depending on the context you're working in. And it's also performant. So those are the two ideas that I think are worth bearing in mind for state management, but actually for pretty much all software development, certainly in JavaScript. And from those ideas, I draw a few lessons about the kind of things I'd want to bring to state management or indeed anything else, which we're going to kind of talk more about. You can read those. Anyway, in February of this year, I think I was bored one evening, and I said, let's create a state management library. This is what people do, right? I don't know. And what would I like in a state management library? So I've probably been using Redux too much over the last year. So basically, I mostly wanted the opposite of that, or something with the good qualities of that without the bad qualities. So I didn't want any of that boilerplate stuff. I wanted auto-completion. I don't want to have to remember stuff. The computer can remember stuff perfectly. I can't. Let's offload that to the computer. Let's reduce that cognitive load. And React Hooks is about to come out. It's in beta. It's going to come out in a few weeks. I should learn about this thing. And immutability, that's awesome. Let's have that. So how hard can that be? It turned out it wasn't that hard, and that's kind of one of the lessons of this talk. It took, I think, an hour and a half. I built this state management library that kind of worked, which I find really surprising. And I was able to kind of summarize the entire state management library in this one tweet. You and I'll kind of, I guess to look at the high level, you define a type in TypeScript for your state. You then create a hook and a provider that goes with that. You can then create components which pull in the, I don't know if I can like point or indicate stuff, but this counter component uses this custom immutable context hook to access and update the state. And then the application simply wraps an arbitrary number of these components with the provider. So the entire everything you need to know about the library kind of can be summarized in that one tweet. Let's look at an actual example. So who's used Code Sandbox before? Okay, everyone whose hands were not raised, you've got to have a look at Code Sandbox. It's really amazing. Like it basically gives you a full modern front-end like web development thing in the browser and like for free. It's completely amazing. But I'm going to try and demo a few little things here. So one of the things with the state management library I did, you define a type for your state. So let's add a new thing to our state. Well, let's say so this is TypeScript if people aren't sort of familiar with it. But I define the type of the state. And so already the compiler, well, the interpreter or wrote the tooling, is telling me I've messed up. I need to provide an initial state, and I haven't provided a name. So let's do that. LNUG. So we've not included this in our state. And if we want to use it, let's pop this into our header. And I don't have to remember stuff. So if I type state, it knows it has a type. So, and the type is LNUG. So we can write things like this. But you know, we're kind of better developers than that. So we're gonna add a feature to the application. So I'm sure we're all 10x developers here. So let's 10x this counter. So we'll create a 10x counter. We're going to copy and paste our code. There's actually, I think this is good for a reason I might get onto. But you know, 10x that, you know, instead of just incrementing it, we're going to like multiply our counter by 10. So you can imagine this is like sales numbers or some kind of business metric or something. And you know, we're gonna. So we've created a component, our 10x counter component. So we're going to drop our 10x counter into our application. And now when we hit our 10x button, we multiply things by 10. So that's kind of how easy it is to pull in and modify the state with this library. One of the qualities I like about it, however, is that you can really easily delete things, which I kind of take to be a really useful heuristic for how do I make a thing that I can change? Well, if I can delete things and that isn't hard, then I'm probably going to be able to change it well. So let's get rid of this old counter. So this is our old like, non-10x counter. So we'll delete it, and the compiler will tell us, oh, it's wrong, so we need to remove a thing in red. And look, we've got a working application again. So I think if you can construct stuff that is easy to delete, easy to change, very easy to pull in, uses a small number of concepts, I think you're doing well. So the lessons, a few very short lessons I kind of draw from this. One, you know, there's this like pretentious quote from Newton. The thing I love about this quote, people quote this really directly, but here's the thing: Newton was being ironic at the time. He was a giant. The people at his time were mostly not. However, we have NPM and JavaScript, so we actually have lots of great stuff we can pull in. And you know, I built this thing in an hour and a half because a lot of other people did really hard stuff, and I glued their stuff together. One of those things is TypeScript. I think TypeScript's remarkable. It kind of takes this sort of mess of JavaScript, you know, this language built in 2 weeks and accumulated over time, and makes it a really pleasant modern language to work in. I think it's amazing that you don't need to write as much documentation, you don't need to write as many comments, you don't need to write as many tests, so you just do way less work overall. That's kind of awesome. You've got this sort of structural typing, which is very lightweight and flexible, and it kind of subtly pushes you towards better designs that are more consistent and in the long run will be easier to work with. And you can make changes with relative confidence. So you saw I made some changes there. I didn't really have to think about stuff. Like coding stuff in front of a bunch of people is like way harder than coding stuff at your desk normally. And I was pretty confident it would work thanks to TypeScript. You can also do TDD. This is not test-driven development, but type-driven development. So I can write the types that I expect, the inputs, the outputs, and then fill out the program. And you can also do some fancy stuff by trying to make impossible states impossible. So you can try and describe in types certain characteristics of the way your system is modeled, such that you simply can't represent invalid stuff. Anyway, on the next lesson is use Emmer. It's amazing. It's the thing that does most of the hard work in what I presented. It's a library that takes an object and a function that updates a draft object. The clever thing with Emmer is that it doesn't actually modify your original object. Through the magic of proxies, it creates a new object which shares all of the unmodified pieces of your old object with the new stuff. But the main benefit is, like, compared to something like Redux, where you have to do various kinds of destructuring and indexing and slicing and so on, you just do the natural idiomatic JavaScript stuff. The next lesson, hooks. You should use hooks. They're awesome. They really lower the cognitive load on React. It co-locates related logic. It makes it, I think the main thing I find, I've been doing hooks sort of mostly full-time for about 6 months now, and it makes it, it's so much more pleasant. I think I find that you have fewer regrets. Like, you don't mess things up. It's so much easier to make changes. It's really easy to extract some custom piece of logic and share that with something else. I kind of think of it as like UI development on easy mode. It pushes that red stuff I talked about at the start right the way to the left till it's barely visible. It gives me all of that mental energy and capacity to think about the actual problem I'm trying to solve, the thing I'm trying to create. I also made a little React Native app using React hooks to learn React hooks. It's on the App Store, it's free, you should download it. The final lesson is about context. So one thing I keep hearing is that we should replace Redux with context. This makes no sense at all. This is like the claim that we should replace a car with an internal combustion engine, because when people use Redux, they're typically using context to supply that Redux stuff, even if indirectly. The thing about context, it provides some kind of value to deeply nested components. We don't have to do the kind of prop drilling, passing stuff down through our component chain. We do something like this. So this is the React hook syntax for using context. Now, you pretty much always want to put that in a custom hook, so you would never even be writing this directly within one of your components. But what do we put in that value? Which brings us on to a quick look at the source code of the thing I made. So this is the main part of Immutable Context, which is the state management library. That was the name I came up with. Yeah, you need a good name for these kind of things. Immutable Context is a really good name. I'm probably going to delete the entire thing and try to do something better, but I'll keep the name, because it sounds like impressive, or at least to me. So first thing to note, this library is really tiny. This is like 82 lines of code, and that's only after I made it significantly more complex by allowing for logic and kind of overriding of the state. So the question of hooks is like, okay, well, the question of APIs in general and hooks in particular is, okay, what is the surface of this API? And it's really, really simple. So the surface of the API is simply a provider and a custom hook. The provider is very kind of standard. You know, it's providing that state value of the state management library. The hook is a little bit more interesting. So the hook is basically, but it's also very, very simple. The hook is simply accessing the context and providing that as its state and providing an apply function. So this apply function is a very small wrapper for Emmer. So this is the Emmer. This is the sort of magical, give me an object, give me a function. I produce a new version of this object without modifying the original. And then that is wired together with the use state hook from React. So you can look at the source code, like it really is very simple. I think this implementation is rubbish. I want to rewrite it completely, but I did this mostly in one evening. So yeah, just to wrap things up, yeah, like you should make things, learn things. You find a bunch of libraries that other people have done all of the hard work and build a little thing on top that kind of pulls stuff together. It's fun, you learn things, and people will probably help you. Like I got Chris helped me with some of the types, so I learned how to actually do TypeScript properly for React components. I've also kind of applied a lot of the lessons I learned from this to when I built something a bit more serious. So one of the things I've been working on recently is a library for doing kind of algorithmic art graphics stuff. So I'll show a little demo of that. So this library makes it kind of quite trivial to write little animated visual pieces of code with like very small amounts of code. And I've applied a lot of the lessons from creating the kind of state management library to this around cognitive load, around using TypeScript, around some of the APIs. In particular, I was kind of inspired by React, which surfaces often a kind of declarative way of writing code. So like here we can see, again, I can't point to stuff here. The top line here, you can see the various lines here pass in a very declarative manner, the configuration, the way you pass in props in React. But it's also, like React, it is procedural in like the local parts, which often works quite well. It's also a bit inspired by Sonic Pi. It's this like Ruby library for doing like live coding music stuff, in that it takes kind of operations to do with drawing. So let's tile this surface and makes that part of the framework. So you can kind of directly do this. So in like 6 lines of code or 5 lines of code, or however you count it, I'm able to make this image, which actually animates through different colors. And this is slightly more code, but it's doing this like quite sophisticated data visualization style thing in like, I don't know, that's like, you know, if you crush together the stuff that Prettier split onto multiple lines, that's like 7 lines of code or something, and you can do something like that. So we got to the end. You can look at the library, which I should probably rewrite at some point. It's on NPM, so you should immediately go back to your workplaces, delete Redux, and start using this library. You'll probably then have to hire me to like fix it or something, so it'll all work out well. You can look at the graphic stuff. There's like demos and things. So I was showing. I showed like some of these demos, but there's lots of these kind of demos that show how to create things, and all of them have the example source code that you can have a look at. I am sort of semi-seriously working on that on like the Immutable Context state management library. Yeah, stuff's in GitHub. I'm Complex View on the internet. Yeah, thank you.